Electrostatic shielding. Electrostatic shielding is also known as electrostatic screening or electronic screening. Electronic screening. Electronic screening. It is a technique that protects a specific region or sensitive instruments from the influence of external electric fields. It is a technique. It's a technique to protect sensitive instruments from influence of external electric field. External electric field. Here is the electrostatic shielding. There is external electric field is applied. So this is the external electric field, and here is this like a cavity inside a metal. So this is the metal surface. Inside the metal, so the electric field is equals to 0. So in the electric field is equals to 0 means, first one, if we choose about the lines of force here, the electric lines of force, so inside field is 0 means this will get cancelled. So field is 0 means what? Net charge inside will be 0. So any sensitive instruments to protect from external electric field we can place so inside this electrostatic shielding. So in electrostatic shielding, net electric field inside is 0, so it cannot be affected by external electric field. Charge distribution on spherical conductor. Charge distribution. So first one, just imagine it's a charge at its center plus Q. Just I'm taking this. Its radius is R. This is the radius. Now it's a plus Q. First thing we need to go for this. Electric field gets terminated. So it's what? Just I'm taking. This is the what is that Gaussian surface we need to take on this surface. So inside this is net electric field is 0. E is equals to 0. This is plus Q, so it will gets terminated, means what? Electric line of force will be traveling like this. Okay, this is, it gets terminated. Definitely it should be what? Minus Q. So next one on this surface, so for the metal, so this is it's a minus Q. Next one, this will become as it's a plus Q. So Q, the flux is equals to 0, the inside the sphere. Flux is equals to 0 means what? Enclosed charge is equals to 0. Enclosed charge is equals to 0. It's what? At the center plus Q we have. Here it should be minus Q because Q minus Q is equals to 0. So for example, if you take one example, I'm taking this. Here, this is what? Two spheres I'm taking here. There are the two concentric spheres which have same center. So its radius is R1, its radius R2. So the charge on this is what? Q1, and next one is Q2. How the charge distribution takes place? So first of all, the charge is, and at the center also I'm taking one more charge, it's a Q. This is Q. So here is a plus Q, it gets terminated. This will be what? It's a minus Q. It's a minus Q. So minus Q, and the surface of the first sphere, it becomes plus Q. So the total charge on this is Q. So here on the surface, on surface of first sphere is equals to q1 plus q, and this q1 plus q, here is what q1 plus q, this again induces on this inner surface of the second sphere. So minus of, it's a q1 plus q is the thing. This is for, here you can say minus q1 plus q, and again it induces on the outer surface of this. This becomes plus of q plus, this is what it's a q1 plus q. Now total charge would become as q2 plus q1 plus q. So q2 plus q1 plus q, so will be the surface, on the surface of this, which one, outer sphere. So from this what you got it understand, initially the charges are q1 and q2, and when the after the charge distribution, the charge on the surface of first sphere, outer surface of first sphere is q1 plus q. This is q1 plus q, and charge on the outer surface, on outer surface of second sphere, outer surface of second sphere is, it's a q2 plus of q1 plus q. So this is outer surface of the second sphere. Like is the charge distribution on concentric spherical shells. How to write electric field and potential in concentric shells. So first the basic information. If I'm choosing about, there is a shell. So here its radius is, let it be, it's a capital letter R. Charge is distributed on the shell. It's a plus Q distributed on the shell. So now I'm writing about potential. So for example, for R is less than R, inside the shell is somewhere, this is what point A I'm talking, and next one is, for example, it's a point B, this is the radius R. Okay, so it's a distance from the center to the point B is R. So for X is less than R, means inside electric field is equals to 0, and next one, potential V is equals to KQ by R, inside is constant, we know already. So next for second one, if R is greater than capital R, okay, so this is what greater than R, equal, you can write it. So it's what E, electric field, KQ by, it's a R square, and next one, it's a potential V is equals to KQ by R, small letter R. Okay, so from here we can observe, just if the any charge is inside the sphere, potential is constant. If any charge is, this is the charge is distributed on this, so charge is just one second, so your charge is distributed on the sphere, so the potential inside will be what, constant, and field is 0 for the same sphere. So if you discuss about, this is the, it's a of the point which is away from its shell, so R is greater than capital R. So with respect to this one, the charge is distributed here, means what, it's like a point charge. Point charge is what, plus Q, like, okay, it's what distributed. So here the potential at inside will be constant, potential outside when you're talking, okay, this is treated as the total charge is concentrated at this point. If it is at this point, what is the potential? KQ by R. Okay, so how to write the electric field and potential in concentric shells. So let me take on this. For the concentric shell, here 3 concentric shells are given. So it's the charges distributed on this one. It's a Q1, next one is Q2, next one is Q3. Let us write how to write its potential and next one fields. First one I'm writing about potential. Potential at A, B and C. So the potentials are, first for example, I want to write at this point, this is what VA. VA is equals to, you can see, A is inside the this first sphere. Potential is constant. What is the constant potential? V is equals to KQ by R1. KQ by R1. If you talk about this one, so inside this second one also, KQ2 by R2. And if you write about this one, KQ3 by R3. Okay. So the potential V is equals to, first one is KQ1. Okay. It's a KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3. Again I'm talking. So this charge is inside of all the shells. That's what potential is constant. I written as like VA. And next one you can write about VB. Okay. So just what VB. B is what, this point. Okay. Just to think about. So this is B. Is the first, here is the point. This is outside the third one. Outside the third shell. Sorry. B is inside the third shell and outside the second two shells, first and second shells. So let it be this distance from here is RB. Okay. So now I'm writing potential due to A at B means what, due to first shell, KQ1 by RB plus KQ2 by RB. Okay. Plus KQ3 by Q3 is constant inside. Inside means what is its radius? R3. So this is R3. KQ1 by, so RB, and KQ2 by RB plus KQ3 by R3. Chalo, VC you can write it. C means what? Here. So this distance is what? For example, RC. So RC is equals to KQ1 by RC plus KQ2 by RC plus KQ3 by RC. Means it is outside from all the shells. So directly we can write VC. And next you can write about what is electric field. Okay. So second one is electric field. So electric field is, electric field, it's a E. Inside the concentric means what? Inside the hollow shell, it is 0. Okay. So let me write first one is EA. EA is equals to, this is the point, which is the point here. This is what inside the shell according to Gauss law. Okay. So net field inside the shell is what? 0. So this is 0. Next one is E at B. EB. So where is the B? This is the point B. So this is what? Outside of these two shells. Means what? What is the total charge accumulated on this? This is Q1. Next one is what? Q2. Okay. So how Q1 and Q2? You know this is Q1. This become as minus Q1. Next one is what? Plus Q1. So total charge will be what? Q1 plus Q2. So I can write K next Q1 plus Q2 by R outside, no, B square, RB square. And potential at C, electric field at the point C. C means for the total charge accumulation. So here charge distribution, Q1 plus Q2 plus Q3. Okay. So the distance is what? RC. This is K times of, then what do you say? Q1 plus Q2 plus Q3 by RC square. Charge distribution on parallel conductors. So first one conductor is taken. Its charge on the conductor is capital letter Q is taken. So this is the metal. So here the field according to Gauss law. So the field inside the metal conductor, it's a 0. Let it be the charge is distributed on this surface. Okay. So you can take about whenever two plates are given, two parallel plates means when this parallel plate, parallel conductor, it means two parallel plates. Okay, these are the two parallel plates. So non-conducting infinite plane sheets. Okay, so electric field due to plane sheet, E is equals to sigma by 2 epsilon naught. So here just we are choosing about this is, it's a Q1 and next one is Q2. Let we consider this one. So if you talk about this is the point, anyway the point is what? Inside this. Yes. So inside this one, it's a net field is equals to 0. Net field is equals to 0 means due to this surface, the field is out, away. Okay. E due to first surface. So due to second surface, E Q2. Okay. So the fields here are, so both the charges are distributed Q1 and Q2 on either sides. Okay, so and next one, the surface charge densities. What are the surface charge densities? Surface charge density of first one is sigma 1. Sigma 1 is equals to q1 by a. Surface charge density of second, so it's a sigma 2. Sigma 2 is equals to q2 by a. So now, sir, here at this point net field is 0. Net field E is equals to 0. So E is equals to 0 means E uh, Q1 minus E Q2 is equals to 0. So E Q1 is equals to E Q2. So this is Q1 by A. Okay. So charge densities I'm talking on this directly. So what is the electric field due to infinite non-conducting sheet? Okay, combination of two non-conducting sheets are this. So these are like you need to imagine these two are the two non-conducting sheets. So this is what sigma 1 by 2 epsilon naught is equals to sigma 2 by 2 epsilon naught. So it's what sigma 1 is equals to sigma 2. Okay, sigma 1 is equals to sigma 2. This is sigma 1 means what? It's a q1 by a is equals to q2 by a, which means q1 is equals to q2. So finally, we got it as. So to become the net electric field inside this is 0. So definitely q1 must be is equals to q2. Okay. So what is the total charge on this plate q? Q is equals to what? q1 plus q2. Okay. Q is equals to q1 plus q2. Then q1 is equals to q2. Then what? q1 is equals to q by 2 and q2 also what? It's a q by 2. This is the charge distribution on either sides of a parallel plate. Okay. So let us take one more example for this. So two parallel plates are taken. These two parallel plates are separated by distance is d. Okay. So now it's a charge. Surface charge densities are given. And next one, due to this, here is the field and here fields both are so getting cancelled like. So let us see what is the charge distribution on these two plates. Okay, so this is what E1 is equals to 0 and here also E2 is equals to 0. This is what EQ1. Next one is EQ2. So this is what again EQ1 dash EQ2 dash. Okay, for second plate. Now the thing to remember, first one 2q is equals to first one you need to write it's a q1. It's a q1. Okay, so remember is the method to solving the problems for everything. This is q1. So first one is q1. Q1 is this and the first side is given as it's a q1. So from 2q, q1 is removed. Now in second plate how much is removed, how much is left? 2q minus q1. So 2q minus q1, so based on Gauss, the total electric field inside will be 0. Okay, so that's what this will become as charge induces minus of 2q minus q1. Okay, so and from 3q, this is removed, means what? 3q minus, okay, 3q, so minus of minus 2q minus of minus, it's a plus, directly I'm writing this. So this is a 3q plus 2q minus q1, like we can write this one. So this now we can say here first one it's a 3q plus 2q, 5q minus q1. Yes, so this will become is a 5q minus q1. Yes, sir, for solving such type of problems, what is the trick? What because we are going to write objective exams, so directly we can use. So for the JEE level, otherwise so for the NEET students we can go for the solving like. So first you divide into the regions. Okay, you divide into the regions. So first region is here. For the first one I'm talking, this is the first one, it's a second. Okay, first plate, just otherwise you can take about this. In the first one it's a 1, 2, 3 and 4. Okay, so last surfaces means what? Left surface of first plate, right surface of last plate have the same charge distribution. Left surface of first plate, left surface of first plate and right surface So right surface of second plate or last plate, okay, any one. So the charge Q distribution, Q distribution, distribution is equals to, we can say 2Q plus 3Q by 2 is the situation. 2Q plus 3Q by 2. Yes. So again I'm drawing this. This is first plate is taken. Next one is the second plate. It's a 2Q and this is the 3Q. So left side. So what is there? It's a 2Q plus 3Q means what? It's a 5Q by 2. Okay. From 2Q, 5Q by 2 is distributed to the left side. Means how much is left? It means 2Q 2Q minus 5Q by 2. So this is what? 4. 4 minus 5 minus Q by 2. Okay? Minus Q by 2. This is minus Q by 2. Charge induces on next plate, first surface, it's a Q by 2. So from 3Q, Q by 2 is removed. So how much is left in the next plate? 3Q minus Q by 2. So this will be 6 minus, it's a 5Q by 2. So is a method for the problem solving for everything. So how much is distributed in the first plate, first surface of first plate, so that the charge, the total charge on the plate minus 5Q by 2 is minus Q by 2. And next one, so from the 3Q, so Q by 2 is gone. So how much is left means it's a 5Q by 2. As I said, so left surface of the first plate and right surface of the second or the last plate. So what must be the charge? 5Q by 2. You can see it is a 5Q by 2 and 5Q by 2.